Alright, section 6.6 is dealing with square roots and the Pythagorean theorem. So the first part, we're just going to simplify some basic square roots. The square root of 25 is just 5, because 5 times 5 is 25. The square root of 49 is 7, since 7 times 7 is 49. Now, when we have a fraction, we're going to do this the same way. But we're going to think about this as two separate square roots. We're going to think about, well, what's the square root of 25? Well, we know the square root of 25 is 5, and we know the square root of 36 is 6. So the square root of 25 over 36 is 5 over 6. Similarly, for the square root of 4 ninths, I'm going to think about this as the square root of 4 over the square root of 9. We know the square root of 4 is 2. We know the square root of 9 is 3. So the square root of 4 ninths is 2/3. Okay, the next one, the square root of 81 is just 9. Now, for the next two problems that I have here, it says approximate to the nearest thousands, okay, which means we want to have 3 decimal places. So what this means I want to do here is I'm going to take my calculator, and you know what, let me pull one up here for us. And so let me clear that out. Okay, so here's my calculator. So what I'm going to do here is I'm going to hit 7, I'll hit my square root button, and so what I want to do is I want to write to 3 decimal places. So let me pull that back up so we can take a look again. So I have 2.6457. So I want to have 3 decimal places. So my number 5 here is the number that I want to round. Since the number directly to the right of that is a 7, that 5 will become a 6. So I have 2.6 or 2.646. Okay. Similarly, for the square root of 54, I'm going to hit 54 on my square root button. On my calculator, I'm coming up with 7.3484. So the number that I want to round is my number 8. Since the number to the right of my 8 is a 4, I'm going to leave that 8 alone, and my answer will become 7.348. All right, so my next problem here says determine what 2 whole numbers each square root is in between. So what I'm essentially trying to do here is I'm trying to get an estimate for my square root of 40, okay? I want to know it's between what 2 numbers. So an easy way for me to do this is to pull up my multiplication table. So I'm going to pull up my multiplication table, and what I'm doing is I'm looking along this diagonal. And if you recall, the number that I had was the square root of 40. So I want to see, along this diagonal, 40 would be between which 2 numbers? Well, 40 would be between 36 and 49. And I know that the square root of 36 is 6. I know the square root of the square root of 49 is 7. So that tells me that the square root of 40 has to be between the numbers 6 and 7. Similarly, I can also do the same thing for 13. So I'm going to pull up my table again, and I'm going to say, okay, well, 13 happens to be between the numbers 9 and 16. I know the square root of 9 is 3. I know the square root of 16 is 4. So the square root of 13 is going to be between the numbers 3 and 4. Continuing with 6.6, the next part deals with the Pythagorean theorem. So the Pythagorean theorem refers to when we have a right triangle. A right triangle means that this angle here is 90 degrees. And what we have what we call the 2 legs, leg A and leg B, and the hypotenuse. And here is the formula for the Pythagorean theorem. A squared plus B squared is equal to C squared. And it says right here, in other words, leg squared plus the other leg squared is equal to the hypotenuse squared. Okay, so my first problem says find the unknown length in each triangle rounded to the nearest thousands. Again, that means 3 decimal places. All right, so what I'm going to do is I'm going to do a stare and compare, and I'm going to look at this triangle here, and I'm going to compare it to the triangle that we have right there. So if I just do a stare and compare, I can see that my number A is 5, my number B is 12, and I don't know what my number C is. Okay, so I'm going to now, let me just clean up this little part here. Okay, I'm going to now use my formula. So I'm going to say, okay, well, A squared plus B squared equals C squared. So A, we said A was 5, that's 5 squared, plus B is 12, that's 12 squared, equals C squared. Well, according to the order of operations, we need to square our numbers. So 5 squared is 25, 12 squared is 144, equals C squared. I'm going to scroll this down just so I have a little bit more room. Okay, so 25 plus 144 should give me 169 equals C squared. Now, in order for me to find C, I need to take the square root. Oops, let me do that again. I need to take the square root of my number 169, and that ends up just being 13, oops, not centimeters, but inches. So let me put inches right there. Okay, let's try the next problem. So in my next problem, what we have is we're looking at now this triangle, and again I'm still going to use my Pythagorean theorem, but I want you to notice that now one of the sides that I know is a hypotenuse. I know the side opposite of that 90-degree angle. So I know in this case that, say, A is 10. I don't know B, but we do know that C is the number 12. So I'm going to go ahead and use my Pythagorean theorem. A squared plus, let me clean that up a little bit. I'll write it down here towards the bottom where I have a little bit more room. Okay, so let's get our pen again. Okay, here we go. A squared plus B squared equals C squared. So that's 10 squared plus B squared equals 12 squared. Following the order of operations, I need to do my squares first. So that's 100 plus B squared equals 144. In order for me to get the B squared by itself, I need to subtract 100 on both sides. That's going to leave me with B squared is equal to 44. And again, I'm going to take the square root of 44 on my calculator, and if I take the square root of 44, I'm coming up with, I'll write it over here because I got a little bit more room, B is equal to 6.633. This is centimeters. Okay, good deal. So let's take a look at the next couple of problems that I have here. And so it doesn't have a picture, but it tells you what the legs are. Again, if you go back and you look at your notes, you look at the formula, the A and the B are the legs, the C is a hypotenuse. So this is sort of like basically telling me that, well, A is 3 and B is 4, and I don't know what C is. Oops. Okay, so let's try that. So we're going to say A squared plus B squared equals C squared. So 3 squared plus 4 squared equals C squared. So that's 9 plus 16 equals C squared. 25 equals C squared. So when I take the square root on both sides, I get C is equal to 5. Let me clean that up a little bit, make a better, prettier 5 for you. There we go, that 5 is beautiful. Okay, for the one that I have right here, again, I know that, say, A equals 5, and I know that C equals 13, but I don't know what B is. So again, using my same formula right here, I'm just going to write it out. 5 squared plus B squared equals 13 squared. So that's 25 plus B squared equals 169. So when I subtract my 25 on both sides, I come up with B squared equals 144. And then finally, when I take the square root of 144 is just 12. And we found the missing side.